Welcome back, folks. So in this video, we're going to talk about finding the domain of this function and also practice using our set and interval notation to write that domain. Alrighty, so whenever I have a fraction like so, or a rational function, I think immediately to what can I not do within a fraction. The big thing here would be dividing by 0, right? So whenever I see find the domain of something, I usually think of what is not in the domain, because that usually seems to be an easier question, at least for me. So one, things that prevent something from being in our domain would be dividing by 0, and the other one would be not dividing, taking the square root of a negative number. That's not happening in this case, so let's figure out when is x squared minus 9x plus 8 equal to 0. I'm not going to take too much time on this part here because we should just be able to factor it to x minus 1, x minus 8. And so our domain cannot contain 1 or 8, because if I plug either of those in, my function will be dividing by 0. So my domain can be, I can write it like so, any real number except 1 or 8. Okay, but let's think, how could I write this maybe a little bit more formally or maybe elegantly? Elegant might not be the best word because you might not think it's elegant, but formally at least, more mathy, more math-like. So I could use set notation here. And the way I would do that is, well, my domain is the following set. So I start off by writing a set with the squiggly bracket. The variable that is our input is x in this case. If I was using, say, g of t or g of theta or something, then that's what would go in here. But since it's just x, let's put an x there. Now x is any real number, well, besides 1 and 8. And so I'm going to write down that x is a real number, but otherwise this is totally optional. And the reason I say it's optional is because unless you're saying otherwise, it's assumed that x is a real number, or whatever the input here is a real number. So that's totally optional, but I'm going to put it there just at least for this example. And then this part, once again, the little bar says such that. So x is any real number such that, well, and then here are the conditions that it has to satisfy. So the only conditions it has to satisfy is that it cannot be 1 and it cannot be 8. And I would just write that like so. X is not equal to 1 and x is not equal to 8. And so if I was reading this again, or you saw this and you were reading it, then you would say the domain is a set of all x's, all real number x's, that are not 1 or 8. That's all this says. Another way I could put this is with interval notation. Interval notation. And it helps to kind of sketch a rough idea of this graph. And here's what it would look like. If you remember rational functions, which is what this is, we got polynomial over a polynomial, then we know that when I plug in 1 or 8, I get, well, on top, it's going to be some number, and then divide by 0. And so that signifies that we have an asymptote, or two asymptotes rather, at x equals 1 and at x equals 8. And so this graph would exist in 3 chunks because all other real numbers are in the domain. And so this graph might look something like so. I haven't checked it out yet, but it might look something like this. Oops, that's... I just totally made this up. I have no idea what this graph looks like. Okay. But since I have 3 chunks, each of those is like its own little mini domain, if you will. And so the question is, how could I write down each of those intervals? So I'll draw out the intervals here in green. My first interval is here, going that way. The second one's in the middle. And the third one is starting at 8 and then going off to the right. And so the question is, how would I write this interval? Well, or each of these intervals rather. So the first one, the domain of this little chunk that I'm going to highlight in yellow, what would that be? If that was the only graph I was interested in, what would the domain of that one be? Well, it goes off forever in the negative direction, excuse me, and then gets infinitely close to 1. And so if I was writing it as inequality, I would write x is less than 1. In the middle here, likewise, we are getting closer and closer to 1 on the left side and 8 on the right side. And so that'd be 1 less than x less than 8. Now, interval notation does not use inequalities, but I'm just getting myself situated. And then I'm going to write the intervals for each of them. And the last one here is going to be x is greater than 8. It actually might help if I write it as 8 is less than x. And we'll see why. The reason I did that is because we're going to read out left to right. And so if I was to put these in an interval, the interval over here on the left side, well, on the right side, it's 1. And on the left side, well, since the left side doesn't really have an endpoint, it goes on forever, it's going to be at negative infinity. Now, since those are my endpoints, I just separate them here with a comma in interval notation. And the question is, are these endpoints, negative infinity and 1, actually part of the interval, part of that domain of that kind of piece of the graph? In either case, it's no. So for when I plug in 1, again, I can't actually plug in 1, as you see by that asymptote. And so I'm going to put a round bracket or parenthesis there. And likewise on negative infinity, whenever you plug in negative infinity, negative infinity is not actually a number, and so it would never have a square bracket on it. It would never actually be included. Here in the middle, again, does not include, so my endpoints are 1 and 8, and my interval does not actually include them, because again, those are our asymptotes, and so I put round brackets right there. Again, be careful of what we're writing. We're writing an interval here. I'm not writing the coordinate 1, 8. That's not what I'm doing. I'm using 1 and 8 to describe this interval, and this interval does not actually include those endpoints. And the last one over here, starting off at 8, not including 8, and then going off to positive infinity. Alrighty? So the last part here is just put them together. My domain consists of these three intervals, excuse me. Let's see, 1 to 8, and then 8 to infinity. And the way I join them is with this big fancy U, which stands for union. Basically means take these three pieces and join them together. This one's kind of funky because you have to have used that union twice because your graph exists in 3 pieces. Alrighty. So hopefully this helped clear up any confusion you might have had on how to use set or interval notation. Alrighty, folks. See you in the next one.